Hello, Aiden. How are you?
I'm fine, thank you.
I'm good. How was your How was your day, Aiden, today? Did you go to school today?
Yes,
Very good. Did you have math class today?
yes, in first class, the first class.
So what did you learn in math class today? What topic?
Um, Symmetry.
Symmetry.
Yes,
So you studied geometry.
yes.
I see. You see. Good. Aiden, your class is 6A, right?
No, 6B.
6B. Oh, 6B.
Yes.
Okay. And today is it March 16?
Yes.
Yes.
Hi, teacher.
Hi, Nargis.
Hi.
Good. So Nargis, you asked for new paper. Did you finish all these questions in this paper?
Yes.
I see. Very good. So last time, if you remember, we did question from 1 to 15, right?
Yes.
Okay. So let's finish this today, and after that, we will move to new paper. And after that, we will do 2016. Nargis, where's your brother?
He's joining.
Okay, good. Okay.
Hello.
Hi. Okay. Guys,
Can I
if
read
you
the question?
let's start. Yes.
Can I read?
Yes.
The product of two numbers is 1000. Neither of the two numbers has 10 as a factor. Find the difference of these two numbers.
Answer.
Okay. How do you do that?
I write 1000. Can you?
Yes, I can see that. So you found prime factorization of 1000, right? That's
Yes.
all our prime numbers. Very good. So 1000, we can write it as 8
125 minus
times
8.
125. Or simply,
Yes.
8 is 2 cubed times here we have 5 cubed. So it says that neither of the two numbers has 10 as a factor. Find the difference of these two numbers. So actually, of course, we can write it in a lot of different ways, right? For example, I can write it as 10 times 100, or I can write it as 2 times 500. I can write it as 4 times 250. But here it says that 10, neither of the two numbers has 10 as a factor, right? So the only way is, as you see here, if I take the first factor as the power of 2, the second one is power of 5, and power of 2 is not a factor, is not a multiple of 10. And also 5 cubed is not the multiple of 10. So that means that here it is 8, and this one is 125. So their difference is, what is the difference? Their difference is 117, right?
Yes.
Okay. Now, guys, actually, they also ask similar question to grade 6, grade 7, grade 8 students. Instead of 1000, let's say, however, if I put 10,000, how would you solve this question? What will be the answer? The product of two numbers is 10,000. Neither of the two numbers has 10 as a factor. Find the difference of these two numbers. Can you do this?
Yes.
So what is it?
Um, Can I answer?
Yes.
It's 625 and 4.
625 and what? 16?
One moment. Yes, my answer is 625 times 16.
Very good. And you see here also in similar way, if you just keep dividing by 2 and 5, we will have
Yes.
here 2 to the power of 4 times 5 to the power of 4, which means that 2 to the power of 4, that is 16, and 5 to the power of 4, that's equal to 625, right? If you just write this 10,000 as a product of two numbers in any different way, that means that I need to take 2 and multiply the other number by 2, which actually creates a multiple of 10. At the time, one of the factors will be 10. So the only way to write 10,000 as a product of two numbers where they are not multiples of 10. And it has, neither of the two numbers has 10 as a factor. It means that none of these numbers should be or shouldn't be actually, what is it, multiple of 10. So at the time, the difference will be 625 minus 16. That's equal to 609, right?
9.
And also now you got the idea, guys. Sometimes they may also, if you ask 100,000, right, you can answer the question. Even they ask now 1 million, right, in similar way, you can answer you can answer the question, okay? Because as you see here, every time we can just write these numbers as the product of the powers of 2 and the powers of or power of 5. Good. Let's move to the next question. All right, then read the, yes.
Okay, I read. Given that 4 factorial means 4 times 3 times 2 times 1 is equal to 24. Find the number of consecutive zeros at the end of 14.
Yes, any idea? What do you think? How do we solve this question?
We wrote for 1 times 2 times 3 times 4 dot and times 13, and 2 times 5 it's a 1 0. 10 it's also is 1 0. And it's a two zeros, no? It's a two zeros.
2 zeros, right? Because here we have 2
Yes.
times 5 actually
2
gives us
times
1
5.
0. And also here we have 10, right? Also we have 1 0,
Yes.
10 times 10. So the last digits will be only 2 zeros.
Zero,
Okay.
yes.
Nargis, is it clear? Did you understand?
Yes.
Okay, guys, if I ask the same question, all right, the same question, instead of this 14 factorial, if I write, for example, let's say 26 factorial, what will be your answer? Think, okay, I'll give you 1 minute. If you just multiply, how many zeros, how many consecutive zeros are there at the end of 26 factorial?
Mr. Customer, I have answered.
Aiden, can you write your answer to the chat box? Let me see. Okay.
Okay.
You will have the same answer or not. There's 1 more minute. Let me also wait for others. Sunai and the Nargis. Who is 1, 2, 3, 4, 5?
Smile.
Ismail. Okay, Ismail. Okay. Guys, write your answer to the chat box. Let me see. I didn't check your answer. Are you sure?
Yes. Yes.
But your answer is not correct, Aiden. Nargis, Ismail, any answer?
No yet.
Okay, time is up. Turan, are you here? Okay. Again, Aiden, Nargis, Ismail here. Aiden, if you actually realize, the only thing is here we need to count how many multiples of 5 do we have, right? Because here we have enough twos, because every after one number, after one each, every 2 steps, actually we have 1, 2. To create zeros at the end, right, we need to actually multiply 2's by 5's. So if you just write 26 factorial, let me just write here 1 times 2 times, here we have 5 times, and I have here 10, and I have here 15, and I have here 20, and I have here 25. Okay. For example, if you multiply 5 by 2, I have 1 0 here. And 10 already we have 1 0. I don't have to multiply by anything. And 15, for example, multiplied by 4 is 60. So it gives us 1 0. And 20, we already have 1 0, right? And now the question is, Aiden, if you multiply, for example, 25 by 4, for example, let's say multiply this 2 to them, how many zeros there will be at the end of that number?
What?
If you multiply 25 by 4, how many
Yes.
zeros there will be at the end of the number?
2.
Huh? It is 2. It is 2 right now, Aiden. Look, now look, how many zeros we have? 1, 2, 3, 4, 5, 6. So there will be 6 zeros.
Yes.
Nargis, did you understand?
No.
No?
No.
No, what is 26 factorial? That means that we are multiplying the first 26 numbers, right? And usually when can we have 0 at the end, right? If there is 10, right? If you multiply something by 10, then it creates 0 at the end of the number. For example, let's say 5 times 10, that is 50. I have 1 0, right? Or 2 times 15, that is 30. It's 1 0, right? Why? Because here this is a multiple of 5 and multiplying this by 2, right? Now, how about if I multiply them together? For example, 50 times 30, 1500. Why? Because here the last digit is 0, the last digit 0. Now the last 2 digits are zeros. So now the question here is, I'm saying that when we just multiply, right, with this, when you calculate this 26 factorial, that means that we need to multiply the numbers from 1 to 25, all the numbers, right? So the question is, how many numbers, I mean, consecutive zeros are there at the end of this 26 factorial. Okay, I'm saying that the only way to create the multiple of 10, right? We need to multiply 2 by 5, right? Otherwise, if you multiply any other two numbers, they will not actually create 0, or they will not be 0 at the end of that number, right? For example, multiply 7 by 9. The last digit is not 0, right? 9 by 5, the last digit not 0. Or 8 times 4, for example, the last digit is not 0, right? The only way to create 0 is I need to multiply 2 by 5. But here we have a lot of 2's, right? The number of 2's here, it is more than 5's, right? So I have enough 2's actually. So the problem is, how many 5's do we have here? We need to count this. So 5, I have 1 5. In 10, I have 1 5. In 15, I have 1 5. In 20, I have 1 5. But 25, I have two 5's, right? 25 means it is 5 times 5. If you multiply this 5 by, let's say, 2, and multiply this by 2, now how many zeros will I have? Here we have 2 zeros, right? So that's why if you multiply this number, the last actually 6 digits will be zeros. Okay, Ismail, did you understand a little bit? A little bit.
Yes.
Guys, if you understand the last question, okay, then we will move to the next question. The same question. Now, what do you think? How many zeros there will be at the end of this number? 55 factorial. You have 2 minutes only. Very easy question.
Yeah, Mom.
I didn't know, no. Nargis, 18, it is too many, I think. Like guys, here, this one, again, I'll just count how many multiples of 5. Here I have 5, right? And after that, 10 and 15 and 20,
Isn't
25,
that 11?
30, no, 35. It is 12 item.
I wrote 12.
40, 45, 50, and
And
55.
I also wrote 12.
12. Did you write 12?
Yes. Yes.
Oh, okay. I didn't. I'm sorry, actually. The answer 13. 13. Okay.
Okay.
Why is it so item? Because here, okay, these 5s, we know that they actually can make 1/10. Here we have 1, 2, 3, 4, right? And how about this one? Actually, it can create 2 zeros. And also, how about 50 item? If you multiply by 2, the answer is 100, right? There are 2 zeros.
Yes.
Right? And also here we have 2 zeros here. And all others only 1. So actually from 5 to 55, we have 11 multiples of 5. But among this also we have 2 powers of 5. That is 25 and 55 because they create 2 zeros. So now I need to add 2 more, right? So how many zeros? There will be 13 zeros at the end of 55 factorial.
Oh,
Okay, Aydın?
yes.
Okay, good. Nargis, is it clear now? Did you understand?
Yes, I understand.
Nargis, if you understood, can you tell me quickly now? I don't give you any time. How many zeros are there at the end of 76 factorial? Let's say it is 76 factorial. Huh? 76
Wait.
factorial. How many?
Wait.
How many?
Wait, please. Mm,
5, 10 until 75, right? How many multiples of 5? If you divide by 5, actually it is 15, right? And also among this, how many powers of 5 do we have? Here we have
Is it
25
18?
and also 50 and also 75. Actually, each one they create 2 zeros. 4 times 25, 100. 2 times 50, 100. 4 times 75, 300. Right? 2 zeros.
Is it 16?
18?
I need to ask 3. How
16?
many?
16.
18.
18.
Oh, yes, yes.
Because here the powers of 25, right? 5. How many we have? Here we have, what is it? 25,
Yes,
50,
well,
75.
wait.
And then actually these numbers 25, 50 or 75, they have 2 zeros, right? And that's why it is 18. Okay, good. Now let's move to the next question now. Okay. Ismail, can you read the question?
Yes. Jerry drives 2,000 kilometers during a trip. He rotates the four tires on the car and tires, 4 tires on the car and 1 spare tire, so that each tire has been used for the same distance at the end of the trip. How many kilometers are covered by each tire?
Ismail, did you understand the question?
A little.
Huh?
A little.
A little. Aydın, did you understand the question?
A little bit.
Nargis, how about you? Guys, why your voice not so clear? Why? Nargis, is my voice clear to you?
Yes.
But actually, I can hear you well. You need to speak a bit louder or... Anyway, I know what's going on here. Okay, here we are going on a trip, right?
Yes.
From A to B. And let's say from point A to point B. Maybe from one city to another city, we are actually having a trip. So the distance between these two cities, let's say it is 2,000 kilometers, okay? And you know that, guys, actually every time when you just go on a trip, right? If you're traveling by a car, usually we have 4 tires, 1, 2, 3, 4. And also in case if actually something happens to one of the tires, we have one spare tire, right? So that means let's say this one is tire 1, tire 2, and this one is 3, and 4, this one is 5. In the question, it says that he rotates the tires. That means 4 tires on the car and 1 spare tire, so that each tire has been used for the same distance at the end of the trip. Now, how many kilometers are covered by each tire? Yes, well, what are you saying? I guess who says?
I said this is 2,000 kilometers.
No. That's not correct. That's not correct. Okay. So now let me explain this item. What's going on here? So as you see here in the question, it say that it's rotating and every tire is used for the same distance. As you see here, each tire has been used for the same distance. Okay. That means that every tire is used and you travel the same distance by each tire. So now I am going to start from here. All right. First, actually, here, let's say, let me just number this. As you see here, this one, tire 1, tire 2, tire 3, tire 4, 5. First, actually, I'm traveling with tire 1 and tire 2, tire 3, and tire 4. So now tire 5 is the spare tire. I just travel a little bit, okay? And after that, I change this. Now I change tire 1 with tire 5. So now I'm using tire 5 and tire 2, tire 3, and tire 4. Now I'm not using tire 1 here, okay? I travel another distance again, another some amount, but actually these distances are the same. Now I change. I have already changed this 5. Right now I'm going to change 2. So now I'm going to use tire 5 here and tire 1 here, tire 3, and tire 4. So now tire 2 is at the back. It's not being used. I travel again here. Now I change tire 2 with tire 3. So now I have here tire 1, tire 2, tire 1, 5, 1, 2. I have 4 here, and tire 3 is the spare tire here. Okay.
Mr. Qasim, what's a
I
tire?
continue this. Wait, let me finish this. Now I change 4 with 3. So now here 5, 1, 2, 3. Now 4 is the actually the spare tire. Okay, so actually that's the last change. But still I will continue and reach my destination here. So that is my destination here. Okay, so when we reach the destination, or when we arrive at our destination, I don't have to use I don't have to change any tire. Now to Aiden, can you tell me, for example, tire 1, how many times is it used here? Look at the tire 1. Here I use, right? And here I use, and here I use,
4.
and here I use 4 times, right?
4 times. Yes.
Okay. How about actually 2, for example, 2 here,
1,
2 here,
2,
2
4.
here, and 2 here. If you look at every tire is used 4 times.
4
okay?
times, yes.
But as you see here, which each actually tire, what distance we covered here, that means that as you see here, how many times did I change? This is a 1 and 2 and 3 and 4 and 5, right?
5.
So that means that 2000 over 5
Over
is
5.
equal to 400 kilometers. So that means
Yes.
that every 400 kilometers, we just change 1 tire, right? Because it says in the question, it's rotating, right? So each tire is used 4 times. That's why here we have 4 times 400. Then with each tire, we have traveled how many kilometers? 1,600 kilometers. Oh, Aiden, what's a tire? You don't know what is a tire? Aiden.
No.
Aiden, you have a bicycle, right? We have 2 tires here, 1 tire and 2 tires. In a car, we have 4 tires.
Okay.
Okay. In motorbike, we have 2 tires, right? Because here, you know, as you travel more and more, it gets, how to say, more damage. So you have to change this. If you rotate this, none of the tires will be damaged seriously, so that you can reach your destination safely. And that's why we are rotating the changing the tires. Okay, Aiden, how do you call that in Russian or in Azerbaijan? Tire?
Teker.
What is it?
Teker.
Anyway, you understood, right, Aiden?
Yes.
Nargis, Ismail, how about you? Did you understand now?
Yes.
Yes.
Okay, good, good. Guys, let's move to the next question then.
Can I read?
Yes, Nargis, read the question.
Jane is at a road junction.
Junction.
Jane is at a road junction with 4 possible roads to her friend's house, but she didn't know which road to take. So she
Didn't know.
Which road to take. So she asked some passerby for direction.
Passerby.
For direction. Your friend's house isn't on road 1. I didn't want to live near your friend, so I moved from road 2 to road 4. I have taken road 2 to the beach before, but I haven't passed by any house. Your friend stays on road 3. If only one of the passerby is telling the truth, on which road does Jane's friend live?
Okay, if only one of the passerby is telling the truth, on which road does Jane's friend live? Guys, when you talk about this kind of logic questions, you should actually understand one thing. Okay, here you are saying that if only one of the passerby is telling the truth, what does it mean? Among these people, they either tell the truth or they lie. Okay, it's not between sometimes they tell the truth, sometimes no. Either they tell the truth or they tell a lie. Okay, so now Jane is at the road junction with 4 possible roads to her friend's house. What do we mean by this? Here he was walking, right? And here we have 4 roads. Okay, this direction, this direction, this direction, and this direction. And all of a sudden, actually, he was here. Okay, he was here, and he doesn't know where to go. And one guy was just passing by. Okay, and he just stopped and asked, "Okay, do you know where my friend lives?" And he said that your friend's house is not on road 1. And let's say this one is road 1, and this one is road 2, and this one is road 3, and this one is road 4. And the second one, actually, he didn't understand, and he sees another passerby and asks, "Do you know where's my friend's address?" And he says that, "I did not want to live near your friend, so I moved from road 2 to road 4. And again, in the similar way, third passerby says that, "I have taken road 2 to the beach before, but I have not passed by any house," which means that actually he's implying that here your friend's house is not on road 2. Fourth passerby, your friend stays on road 3. Okay, guys, now maybe you may want to try. Okay, if you really want to try, you may give it a try, but that is not such an easy question. All right, but now I'm going to show you the method. How should we solve this kind of questions? Okay, to do this one, all right, I suggest you to make a table. All right, so here we are talking about 4 people, right? Let's say this one is, let me just make a table here: passerby 1, passerby 2, passerby 3, and passerby 4. Okay, anyway, so, and after that, here we have road 1 and road 2 and road 3 and road 4. Okay, so now I'm just going to tick if they imply that he is living on one of the roads, and I just write cross actually if he's not implying any road. Okay, now let's continue. Aydın, can you read the first passerby statement?
Okay, your friend's house is not on road 1.
What does it mean, Aydın, here? What is it trying to say here?
Because it's a friend is not on road 1.
Okay.
He say your friend is not on road 1.
So that means that from this statement, Aydın, what do you understand? We understand that maybe your friend is living on road 2 or 3 or 4,
road
right?
3 or road 4. Yes.
So that means that for sure it is not in road 1. So he's saying that maybe it is here or here or here. That means that actually one thing you should understand very well here. That means that if his friend lives in road 2, road 3, and road 4, that means that he's telling the truth. He's not lying. If his friend lives on road 1, that means that he's lying because he's saying that your friend's house is not on road 1, right? Okay, Nargis, read the second one.
I didn't want to live near your friend, so I moved from road 2 to road 4.
Okay, what do you understand from this sentence, Nargis?
The road 2 is near the friend's house.
No, that means that that means that I didn't want to live near your friend, so I moved from road 2 to road 4. That means that his friend's house is in road 2, right?
And
okay, road 2. Road 2, because he's saying that I did not want to live near your friend, so I moved from road 2 to road 4. That means that he was living near his friend's house, right? Which means that they were both living on road 2. And that's why he moved to road 4. That means that actually he's saying that his friend is living in row 2 and he moved to other road. That means that he's not living any road, right? That he's saying that his friend lives in row 2. Okay. Ismail, read the third one.
Okay, third one. Second possibility. Third possibility. I have taken road to the beach before, but I haven't passed it by any house.
Okay, what does it mean? It means that I have taken road to the beach before, but I have not passed by any house. That means that your friend does not live because nobody lives there. He's saying that nobody lives there, and particularly also his friend does not live there. So that means that he's saying that your friend's house is not in road 2. That means that
I write
maybe
Jane's friend
road
live
4,
in
maybe
road 1.
road 3, or maybe road 4. And the last one says that your friend stays on road 3. And he's saying that your friend's house is road 3. That means it's not in road 2, not in road 1, and not in road 4. Okay. So now if you look at this table, all right, Aidan, can you tell me in which column actually we have only one truth?
Yes.
Which one? Which column? Tell me.
Road 3. Your friend stays on road 3.
No, no, no. You cannot see that. I don't. Look at the first column. Look at the first column. How many truths do we have?
1.
Only one. As you see here, only one. That means that all others, they are lying, right? Only one. So in 2, for example, here 2 people, they are telling the truth. 2 people, no. In the third one, actually 3 people are telling the truth, right? And 1 person is lying here. In the last one, again, 2 people telling the truth. 2 people are lying here. But in the question, it says that if only one of the passerby is telling the truth. So that means that only the first column, right? Only here, only
Passer 3. Sorry,
1 person telling the truth. That means that the answer is, where is his friend's house? In road
2.
road 1.
1. Yes,
One.
Look at
I
this,
write
road
road
1.
1.
Right?
Yes.
Yes.
Okay. In this kind of question, guys, if you make a table and you can see that because this cross and tick, that means that who are telling the truth, who are lying, and what is the result here. Okay, let's move to the next question then.
Can I say?
Did you solve it?
Yes.
How did you solve it? Can you tell me? Can you just...
If area of the square is 36 centimeter square centimeter, so
Okay.
the one side of the square is equal to 6. And
Okay.
unshaded rectangle is 48. And rewrote L plus W times 2, it's equal to 48. And equation says finds the total area of the shaded rectangles. So we wrote L and W, and the finds total is equal to 6 times L and 6 times W. And I wrote 6L plus 6W. It's equal to 6 times L plus W. And we know L plus W is equal to 24. And 24 times 6 is equal to 144.
All right, very good, Aidan. That's nice, very good. I really appreciate that. If you could solve like this, that is very good. So simply here, what's given here? It says that if the perimeter of the unshaded rectangle, right, is 48. So what is this? That big one is unshaded rectangle. And suppose that its length is A and its length width is B. At the time, this one is, we know that it is 6, right? And this one is also A. Opposite sides are equal. And also this should be B. And let's say this one is area and this one is also B. What is A from here? A is length, which is A, width it is 6. So that's just equal to 6 times A.
Times A plus
Yeah.
6B.
It is 6 times B. So the total
Yeah.
area, it is A plus B. That's
B
equal to 6A
6A
plus
plus
6B. And 6 is a common factor. So we can just
A
write it as
plus
6
B.
times A plus B. On the other hand, right, also it's given that the perimeter of the rectangle. So that this perimeter is, it is 2 times
48.
length plus width. A plus
Yes.
B That's equal to 48.
48
Now
divided
from
2 is
here,
equal to 24.
that's right, very good. That's equal to 24. So now if you substitute here, 6 times a plus b, its value is 24. That's equal to 144 centimeters square.
Square.
Dot, dot, dot. The area of the shaded region is 144 cm squared. Okay, very good. Nargis, is it clear?
Yes.
All right. Aiden, read the question.
Okay, what are the dimensions of a cuboid that is made from 2015 1 centimeter cubes if all the sides of the cuboid are longer than 1 centimeter?
Okay. It says that what are the dimensions of the cuboid that is made from 2015 1 centimeter cubes if all the sides of the cuboid are longer than 1 centimeter? First, we should actually draw this kind of geometric questions. Okay, we are talking about what is a cuboid, Nargis? It's just a matchbox, right? Do you know what is matchbox, Nargis?
Yes.
Or any box, actually, that's a cuboid, right?
Yeah.
Okay, that's our cuboid. And this one is length, and this one is width, and this one is height. And how do you find the volume? We know the volume is equal to length times
Length times
width
times
height.
height.
And in the question, it says that if all the sides of the cuboid are longer than 1 centimeter, right? And what do you think, Aiden? Do you have any idea how do you solve this question?
Can I draw, for example, L plus 1 times W plus 1 times height plus 1?
No need to do like this, because here we are using 1 centimeter cubes, right? What does it mean from here, Aiden? That means that L, W, H, all of these numbers, right? L, W, and H, they are, what is it? Whole numbers.
Yes.
Number one. And after that, for example, 2015, let's just find it is prime factorization. 2015, and we know that's divisible by 5. I can divide it by 5. It is 403. And how about 403? Is it divisible by 3? No. But last time I
19.
It is divisible by 19, right? If you remember, if you divide it by 19, 5 times 400, okay. No, it's not divisible by 19. How about
13,
right? Okay.
Yes.
So it is 13. And what is the answer? It is 31.
31, yes.
31, 1. So that means that the only way to write this 2015 as a product of 3 whole numbers is, what is it? It is 5 times
13
times 31. Okay. So it says that if all the sides of the cuboid are longer than 1 centimeter, what are the dimensions? So actually we need to start from the longer side, right? What is the length? It is 31 centimeters.
31.
And how about the width? It is 13
13
centimeters. And how about the height? Height is 5 centimeters. Okay.
Yes.
Yes.
Good.
Can
I say?
Yes. Nargis, read it first, and after that, first let's understand the question, and we will discuss.
Okay. A number gives a remainder of 3
Remainder,
when
Nargis, remainder.
Remainder of 3 when divided by 10. Another number gives a remainder of 4 when divided by
Nargis,
10.
you know the
Remainder.
Another word like this, reminder. Reminder means actually remind something, right?
Yeah.
But this is a remainder. Remainder. Remain. Remind. Remain. Okay.
Remainder of 4, yes, of 4 when divided by 10. The sum of these two numbers is multiplied by 6 to give the third number. What is the remainder when this third number is divided by 10?
Can answer.
Yes,
And
ask and tell me how you did this.
My answer is 2. 2. Remainder is 2.
How? Why?
A number it gives a remainder of 3 when divided by 10. It's for example 13 or 23 or 33 or
Yeah, just give
43.
one number, right? It is one
One number,
number. It
for
is
example
13.
13.
Okay.
And
Another
when
number.
remainder 4, it's for 14 or 24.
Very
We wrote
good.
for 14, and we sum of this number multiplied 6. So 3 plus 4, it's 27, and 27 times 6 is equal to 16, 162. And when is 162 divided 10? The remainder is 2.
Okay, the last digit, right? It gets divided by
Yes.
10, just remainder is 2.
And
Very good.
look
That's it. Very easy.
last, yes,
Okay,
last, yes.
yes.
good. Very good.
Mm.
This is a little bit hard question, and not too hard, but you need to think. Okay, it says 1 and 2 is written twice, 3 is written 3 times, and 4 times, and it continues in this pattern. If I write 5, for example, 5 will be written 5 times. The question is, find the 2015th term of the following sequence. Ismail,
see
what
my
did you get?
camera?
Yes, I can see that. Very good. What did you get?
I write 62.
62. Okay, if you just write, because here what's going on here, right? And we just continue here, and we should just guess. We know that actually 1 is written once, 2 is twice, and 3 times, right? 2015. That means that if I just calculate, for example, what number, like n, let's say times n plus 1 over 2, right? Because what is this? We know that that's equal to 1 plus 2 plus 3 plus 4 plus, right? So that means that here, after some number like n, n, and this one n, it is written how many times? N times. I'm just counting how many digits do we have here, right? If you count this, it is, for example, that's equal to n times n plus 1 over 2. And that is the sum of the first n natural numbers. And that is equal to, for example, as you see here, suppose that that's equal to 2015, but I'm not sure, okay? Now, if you find this, that n times n plus 1 is equal to 2 times 2015, which is equal to 4030, right? And we have 2 consecutive numbers, right? How can I approximate this then? This n should be approximately equal to square root of 4030, right? And what is square root of 4030? It is 20 times 20. It's not 20 times 20. What is square root of square root of 4030? It's about 63 something. All right, 63 something. So that means that if I suppose that if n equals 63, for example, let's say here we have 63, 63, 63, and when I just count this until here we have 2015 terms. Then here we have 63 times 64 over 2. That is the sum of the first digits, right? That's equal to 63 times 64 over 2. That is 32. And what is 63 times 32? That's equal to 2016. 2016. Okay. So that means that if you just write 1, 2, 2, and just continue here, here we have 63, 63, and dot. Here we have 63. How many numbers do we have here? Here we have 2016, right? So the last one is 2016. And before this one also, it is 63, because here 63 is written 63 times. So the answer is, Ismail, is it 63?
Yes.
Okay. Okay, Aydın, did you understand?
Um,
Aydın, that
Yes.
is if you didn't understand, but even if you understand a little bit, but I suggest you to try this one more time, okay? Because if you really understand, you learn a lot of stuff from this. Usually in a lot of math Olympiads in Sasmo, they ask similar questions. And that is very, very important question, okay? You should understand the idea. What is the main idea here?
I will
Huh?
understand.
Okay. All right. That is the last question. Actually, we have 22, 23, 25, and let's finish with this. Sunai, are you here? Sunai.
Yes, yes, I'm here.
How about Ulker? Ulker, are you here? Turan, how about you? Okay, Sunai, can you read the question? Sunai,
Yes, yes.
read the question.
Hall, 8 of chairs are arranged in rows 7 and 5 of the chairs are arranged in rows of 11. The rest of the chairs are stacked up. If there are less than 2,000 chairs in the hall, find the total number of chairs in the hall.
Thank you, Sunai. Thank you. Nargis, what do you think? Do you have any idea or did you solve it?
No.
Aydin, how about you?
No.
Okay. Here, yes. All right. Guys, let's do this then. In a school hall, 8/13 of the chairs are arranged in rows of 7. Okay. And the 5/13 of the chairs are arranged in rows of 11. So the rest of the chairs are stacked up. If there are less than 2,000 chairs in the hall, find the total number of chairs in the hall. Okay. So what does it mean? It means that here, now again, suppose that altogether we have n chairs, okay, in the hall. All right. So in the first part, it says 8/13 of the chairs are arranged in rows of 7. What does it mean? It means that 8/13 of chairs, that is times n, right? They are arranged in rows of 7 means that here that is divisible by 7. Let me just write here by capital A. All right, that means that 7 times A means that is divisible by A, right? Because 8/13 of n are arranged in rows of 7 means here we have some chairs. Actually we're just filling some rows, right? And each row we have 7 chairs. Anyway, and also it says that 5/13 of the chairs are arranged in rows of 11. So that means that 5/11. Oh, sorry, it is 5/13, right? 5/13 of chairs. They are arranged in rows of 11. So here we have 11 times some number B. I don't know actually how many rows actually they have 11 seats. How many rows they have 7. That's why I'm just using A and B. Okay. Now from here, the rest of the chairs are stacked up. 8/13 and 5/13. And if you just add them, okay, it gives us all the chairs. Okay, arranged in rows of 11. The rest of the chairs are stacked up. If there are less than 2,000 chairs in the hall, find the total number of chairs in the hall. Okay, good. Guys, I will check this before this. Just let me look at the original paper because 8/13, 5/13 is equal to 13/13. It gives us all the numbers, right? It is 2014 P6 question 24. Just give me a minute. 2014, P6. And the last question. Is it P6?
Yes.
2015, sorry, it is 2015, right? Why did I write here 2014? Oh, okay, I need to change this. All right. (2015). Okay. 8/13 of the chairs and 5/13 of the chairs are arranged level are stacked up if they're less than. Okay, I got it. Anyway, let's get back to our question. Nothing is wrong. Okay, we will see that. Anyway, guys, if you just add side by side, what do we see here? Here we see that actually 8/13 times n plus 5/13 times n. That's equal to 7a plus 11b. Okay, so as you see here, 5 plus 8 plus 5, it is 13. 13/30 is just equal to 1. So here we have n, the number of chairs, that's equal to 7 times a plus 11 times b. Okay. So the rest of the chairs are stacked up. If there are less than 2,000 chairs in the hall, find the total number of chairs in the hall. Okay. So guys, I will stop here. Okay, we will continue next time. Something is missing here because if it is like this, we have a lot of answers. One information is missing. Let me just check the correction paper. They must have corrected this later. Okay, and we will discuss this next time. Okay, so now Nargis, because in this way we cannot solve this question. Some information is missing here. I will correct the mistake, and after that we will discuss this question again. All right. Okay, guys, thank you very much. I will meet you on, when is it? Aydin, when is our next class? Friday?
Friday
yes.
at 8.
Okay, guys, see you on Friday. Okay, see you. Take care. Bye bye.
Bye, teacher.
Goodbye.
Bye.
Bye bye. Thank you. Bye bye.